Hello everyone, we are taking the chapter 1 of class 8 today, that is the rational number. And starting with the rational number, by the definition that any number which can be written in the form of p upon q, means you can also use the word represented. Any number that can be represented in the form of p upon q where it has three conditions, and those three are p and q should be integers, q shall not be 0, that means the denominator cannot be used as 0. Later on, the third and the last condition should be p and q should be co-prime. Now if you do not know about co-prime, that means the HCF of p and q should be 1. Now for an example, we can have 2 upon 3 where the HCF of 2 and 3 both are 1, and q, since the denominator, this area represent q, this represent p, so both are integers. If we are talking about the integers, so we can have negative as well, so minus 17 upon 23 or minus 3 upon 16. Now for your information, for the co-prime, two prime numbers are always co-prime. A prime number and a composite number is always co-prime. Co-prime are those numbers whose HCF is always 1. Okay, so here was the rational number, summarizing the entire thing. A number that can be represented in the form of p upon q where p and q are integers, q not equals to 0, and pq should be co-prime. This is your rational number. So your introduction has been done. Now we are moving toward the properties of the rational number. To begin with the properties, you have always come with the first property, that is closure. Now what is closure property? Closure property means there are four conditions. Closure properties like of whole numbers, closure property of integers, and closure property of rational number. These two, the first two, you have already done in the previous classes, that is 7th and 6th. However, we are going to revisit them. Revisiting means the closure property for the addition, subtraction, multiplication and division. That implies if you add two whole numbers, if you are adding two whole numbers, you are getting a whole number. That means you already know, so you can add 2 plus 0, it will be 2. You can add 3 plus 5, you will be getting 8. So you add any two whole numbers, you will be getting a whole number. While subtracting, so you subtract 2 minus 0, it is 2, but you can't subtract 3 minus 5, so it will be minus 2, which is an integer. So you are not getting an whole number while subtracting two whole numbers. You are getting an integer while subtracting two whole numbers. Multiplication, yes, we can say it is possible. Taking the same examples, this will be 15. While division, you can divide but not always, as 2 cannot be divided by 0. However, we are taking the another example. 3 divided by 5 will give you a number that is in the decimal. So this is also not a whole number. So summarizing this thing, we can say closure property holds true for only addition and multiplication. That means closure property is true in case of whole number in only two cases, that is, one is addition and the other is multiplication. Now taking up the integers, for the addition, if you add two integers. Let's say we are taking -2 plus 3, so this will give you a 1. And if you are adding -3 plus -5, this you will get as -3 -5, this is -8. So you are getting an integer while adding in any form, so that means it holds true for the addition. Now while subtracting, taking the same examples, -2 -3, so this is -5. Yes, it is true in this case also. -2 multiplied by 3 -6, it is true for this also. And -2 divided by 3, now this will not result in a integer, it will come into the decimal. So we can say that in case of integer, it is true for addition, subtraction and multiplication. 3 cases. Thus, now coming to our main topic, that is rational number, which we will take separately. We are taking the addition of the rational number over here. Now taking up the 2 examples, let's say 2 upon 3 plus 4 upon 5. Taking up the LCM, this will be 15. Dividing 15 by 3, you will get 5. And this will be multiplied as 10. This will be multiplied as 10. Now 15 divided by 5, this is 3, and this will be 12. Alright, we were discussing about addition of 2 rational numbers. So this got 10 and here is 12, so it will give you 22 upon 15. Now 22 upon 15, you can't find out any common factors between this, so it will be a rational number. While if you take -2 upon 3 added to 4 upon 5, the same LCM will be here, and this will be -10, this will be 12, and this will result as 2 upon 15. So this I have deliberately taken this number as a negative rational number. Negative rational numbers, so adding whether the 2 positive rational numbers or adding a negative or any positive rational number, you will always get a rational numbers. So it implies that if you add 2 rational numbers, you will get a rational number that is a closeness. So adding 2 rational numbers will always give you a rational number. Now we are subtracting 2 rational numbers. So we can have the same, we are testing for subtraction. So 2 upon 3 minus 4 upon 5, LCM will be 15, this will be again 10 minus 12, so this is now -2 upon 15, which is a negative rational number. So it is true in both the cases. Now we are checking for multiplication. So 2 upon 3 multiplied by 4 upon 5, so numerator will be multiplied with the numerator and denominator will be multiplied with the denominator. So this will be 8 upon 15. So this is also an rational number. If we take any other example, let's say we are taking -6 upon 7 multiplied by -4 upon 13. So this will be the same, numerator will be multiplied with the numerator, so this will be 24 and this will be 91. So we can say that if you multiply 2 rational numbers, you will get a rational number. Now what we are checking for? We are checking for division. We are checking for division. Now 2 upon 3 divided by 4 upon 5. If it implies 2 upon 3 will be multiplied by 5 upon 4. So this will give you 10 upon 12. This will give you 10 upon 12. And if simplifying this, you will get 5 upon 6, which is a rational number. Alright, but if we check another case, for division, another case for division, like if since this is 0 and you are dividing this by 4, so the result will be 0. But can you divide 4 by 0? This will be not defined. Now, just because of such cases, this rational number is not closed under division. Alright, now how could we say that 0 is a rational number? Condition, is 0 a rational number? Now we can debate on it, but if we check an example, can we write 0 upon 1? Yes, we can write. Can we write 0 upon 17? Yes, we can write. Can we write 0 upon minus 23? Yes, we can write. Now checking up the conditions for the rational number, it should be upon P upon Q form. So which says Q shall not be 0. So the denominator is not 0 in any of the cases, but the numerator can be, because there was no such conditions. That is why 0 is a rational number. So we cannot say that division is a closure property true for rational number. So for the rational number, only addition, subtraction and multiplication, these three holds true for rational number under closureness. Now the other is commutativity. Now if you recall the general form of the commutativity, so we will have three conditions. Again, one we will have for whole number, this we will have for integers, and here we will have for rational number. Now the general condition, if you recall, a plus b should be b plus a. This is the general condition for addition. Alright, so addition, so I am writing a plus b should be equal to b plus a. For subtraction, a minus b should be equal to b minus a. Multiplication, a multiplied by b should be multiplied by equal to b multiplied by a. And for division, a divided by b should be equal to b divided by a. Now let's have a few examples. Taking two whole numbers, 2 plus 3, is that equals to 3 plus 2? In both the cases we are getting 5. Yes, that's true. Taking the same examples, 2 minus 3, is that equals to 3 minus 2? In this case minus 1, which is not an whole number, so it got untrue over here, and this is 1, and both are not true, so this is not true, and this one is true. Now 2 into 3 is equals to 3 into 2. Is it 6 and 6? Yes, it is true. So we will get the tick mark right over here. And now for the last one, 2 divided by 3 should be equal to 3 divided by 2. Sorry, 3 divided by 2. Both are not the whole numbers, so this isn't true. We'll use the red pen. So that means commutativity for the whole number is only true for addition and multiplication. Now shall we check for the integers? The same conditions. So we are taking two examples. Let's use one of the negative ones. Alright, so minus 2 plus 3 should be equals to 3 plus minus 2. Now be very careful, we are adding a negative integer. If we use the direct negative sign, so it will imply that we are subtracting. So this will be plus minus minus, you will subtract it, 1 3, opening up the bracket, plus minus minus, so So 1 is equals to 1. So that means integers are true for the addition. Now shall we check for the subtraction now? So again we will have the same examples. Minus 2 is being subtracted with positive 3 equals to positive 3 is subtracting a minus 2. Well, now minus 2, this is minus 3, this minus got plus, so this is minus 5 and this is plus 5. It implies that it is not commutative while the addition was commutative. Shall we check for the multiplication this time? Minus 2 multiplied by 3 should be equal to 3 multiplied by minus 2. Well, in both the cases the result is similar, that means it is true. Now we will be checking for the division. That means minus 2 if divided by 3 should give us same result when 3 is divided by minus 2. Well, if you will divide 2 by 3, both are not divisible, so they are not going to give you an integers, they are going to give you a decimal numbers or the rational numbers, but we want the same answer which is neither true in any cases. So we will conclude that this is also not true. So we will say commutativity of integers is only true for addition and multiplication. Commutativity of integers is as like as whole number, and it is true only for the case of addition and multiplication, and it is not true for subtraction and division. In both the cases, subtraction and division. Now let us check for rational numbers. We will choose the same 2 upon 3, add it to 4 upon 5. Is it equal to 4 upon 5 plus 2 upon 3? Same 15. So this is 10 plus 12, 15, 10 plus 12, and this is 22 upon 15, that is equals to 22 upon 15. That means in both the cases it is true. You should also take the cases of negative integers. You should also take the cases for the negative integers, and you should find out whether they are true or no. If we take for the case of subtraction, so we are using this example over here. 2 upon 3 is subtracted from minus 5 upon 5. 2 upon 3 minus 5 upon 4. This should be equal to 5 upon 4 minus 2 upon 3. Let's check. Now the LCM is 12. You divide 12 by 3, the result will be 4. 4 is multiplied 2 to 8. Divide 12 by 4, the result is 3 multiplied by 5, 15. Again 12. This will be your 15, this will be your 8. Here it will be minus 7 upon 12, while here it will be 7 upon 12. The difference is of negative numbers. So we can say that commutativity is not true for subtraction, while it is true for rational numbers. Now check for the multiplication. If you are checking minus 2 upon 3 times 4 upon 5, is it equal to 4 upon 5 times minus 2 upon 3? Yes, in both the cases you are going to get 4 to the 8, that is minus 8, and 5 is a 15. 4 to the 8 minus 8. Yes, so we can say this is true. Now let's check for the division. Minus 2 upon 3 divided by 4 upon 5. This should give a result similar to 4 upon 5 divided by minus 2 upon 3. Well, you know about how to divide, that you have learned into the class 7. So you need to change the sign of division into the multiplication by reciprocating this. Is it that equal to 4 upon 5, change the sign, and this will be 3 upon minus 2. Now it will not be equal, as this is going to cancel, but this is 5 upon minus 6. This is, you are getting 5 upon minus 6, and this you are getting, if you are cancelling this, you are getting 6 upon minus 5. So these are not equal. So again commutativity becomes easier for us, that commutativity is true for addition and multiplication in all the three cases, that is whole number, integer and rational number. So we can conclude that whether it is a whole number, integer or rational number, it is not true for subtraction and division, and it is true for addition and multiplication. Now we are taking up the another property, that is associativity. Well, to identify whether the associativity is working, where the associativity is applying and where the commutativity is applying, you should be knowing that whenever more than two type of numbers are working, they are actually applying the associativity. Well, if we take the case of whole number addition, that means if I say 2 plus 3 plus 5 plus 4, this should be equal to 4 plus 5 plus 3 plus 2, or 4 plus 3 plus 2 plus 5, or 5 plus 2 plus 3 plus 4. That means if there are more than two numbers, you add them in any order, the result should be similar. If such is the condition, then it is known to be a property of associativity. That means it's not always whether there should be three numbers or four, more than four, and that too, that if you are adding them or subtracting them in any order. So this is always 3 plus 2 5, 5 and 10 and 14. So this is giving you the result 14. 4 plus 5 9, 9 plus 3 12 plus 2 14, 4 plus 3 7, 7 plus 2 9, 9 plus 5 14, 5 plus 2 7, 7 plus 3 10, 10 plus 4 14. That means if you have added them in any order, the result is similar, thus it is known as associativity. Now you should be checking one thing, like if I make you look into the thing, if the two things which were added back like in reverse order, if they were similar, only then the four things will be similar. No, if it is untrue for only two of the things, like we were subtracting from like A to B and B to A, it became untrue, then how is it possible that it will become true for the four of the cases? Well, let's see. If we are checking for the subtraction, so 2 minus 3 and minus 5, we are taking for the 3, should be equals to minus 5 minus 3 plus 2. Now this you should be checking as like this. Wait, we are supposed to subtract this now. So you are subtracting 2 minus 2 is being subtracted from 3 minus 5, so we are taking this as positive. Now we will take it as 2 minus 3 minus 5, like this. Alright, so it implies we need to first solve this, just in the case we did separately. So 2 minus 3 minus 5 will give you minus 2, and this minus minus plus, and this is giving you 4. However, if you solve this bracket, you are going to get minus 1 in the bracket and minus 5, so this will be minus 6, which is not true. Even this is not even a whole number. So my point is, when they were not true for the two items, how could they be true for the four? So sufficely telling that associativity also goes just like commutativity, so implying that associativity for addition, subtraction, multiplication and division. Writing over here, if I write whole number, integers and rational numbers. So, well, we just checked out that it was true for addition, it isn't true for subtraction, and it is not true for division. However, it was true for the multiplication. Now, similarly, integers were, since commutativity was true for the addition and multiplication and it wasn't true for the subtraction and division. Since it was not working for the 2 items, so how could it work for the 4? Well, you can also try with having the different examples, or we can have just the examples from the books. Now, rational number. So the rational numbers are true for addition. Rational numbers are not true for subtraction. Rational numbers are true for the multiplication, and rational numbers are not true for division. That means division is one such property which is not true for anything, neither the closure property, neither the commutative property, nor the associative property. Having an examples for the rational numbers, if we check in the picture, this addition has been done for 3 items, like where they have summarized over here a plus b plus c and is equals to a plus b plus c. That means if you are adding a to the sum of b and c, while here you are adding c with the sum of a and b. Let's check over here. This is a minus 2 upon 3, b is 3 upon 5, and c is minus 5 upon 6. So you are solving first this bracket. 5 and 6 LCM taken is 30, and if you will solve over here, it will be minus 7. Now 30 and 3 LCM is 30, this will be minus, if you will divide, minus 10, this will multiply with minus 2, so it will be minus 20, and this is 30, so 1, so minus 20 plus minus 7, so this is minus 27 upon 30. Simplifying, omitting the HCF, this 3 was common, highest common factor was 3, so you have solved it as minus 9 upon 10. So this has given you a rational number. Now checking it in other way, like you are adding minus 2 upon 3, 3 upon 5 first, and later on the sum is to be added with the minus 5 upon 6. Taken the LCM 3 and 5 as 15. Solving out the numerators, you will get minus 1 upon 15. Now this is to be added with minus 5 upon 6. The result is still minus 9 upon 10, which implies that addition is associative for rational numbers. Subtraction is not possible. Multiplication is true, which we have done over here. So in algebraically, if you are explaining this, so algebraically you will write that a is multiplied to the product of b and c. Here the product of a and b is being multiplied with the c. Thus check over here, this is a, this is your 5 upon 4 is b, and 2 upon 9 is c. First coming up with the product of this 5 into 2 10, 4 into 9 36, and this is being multiplied with this. Solving out, simplifying this, you will get 35 minus 35 upon 54. Now this 2 will be multiplied first, and with the product of this you will multiply 2 upon 9, minus 7 upon 5, 3 upon 4, that is equals to 2 upon 9. We can check over here, minus 7 upon 3 times 5 upon 4 into 2 upon 9. So 7 5 is 35, 4 3 is 12, this is multiplied with 2 upon 9. Now minus 35 into 2, this will give you minus 70, and 12 108. Solving out with 2, you can, this will be minus 35, this will be 54. Again minus 35 upon 54, here you were getting minus 35 upon 54. So we have conclusively, this was for the associativity and also commutativity. While in the closeness it gets true for the integers, the rest are as it is, and also the rational numbers. So in the closure property, these two are additionally added. These were the properties. Now after these properties, we will come with few other properties. Those are the role of 0. Now the role of 0. Now whether you add 0 with a whole number, with an integer, or with a rational number, you will always get the same number itself. That is why the 0 is said to be a additive identity. 0 is known as additive identity. Pardon me for the writing, it's too bad. Alright, so the role of 0 is also known as additive identity. Okay, similarly we'll check the role of 1. For the whole number, 2 into 1, 2, minus 3 into 1, minus 3, minus 4 upon 5 into 1 is minus 4 upon 5. So what we can conclude about 1? That this is known as multiplicative identity. 1 is known as multiplicative identity. That means 1 is such a number, if it is being multiplied with any of the item, it will give the item itself, or it will give the number itself. So 0 is known as additive identity, 1 is known as multiplicative identity. I hope you people are making the notes. Secondly, now we are going toward a new topic, that is negative of a number. Negative of a number. Well, for the negative of a number, I am stating few examples for you. Let's say 2 upon 3. One is the example, minus 17 upon 16, and this is minus 230 upon 117. Now negative of a number means, what can be the negative of this number? A number itself with the negative sign. What will be the negative of this number? A number itself with the opposite sign. And what will be the negative of this number? A number itself with the opposite sign. So now let's check. There is one property, 2 upon 3. If this is added to its negative, okay, number is minus 17 upon 16. This is added to its negative. Now this was already positive, so I haven't placed the positive sign over here. However, you can also put, but there is no requirement. Now this was the number, it is been added to the negative of this number. Now these are the negatives. Negatives means the opposite of the sign. This was positive, so its negative is negative. This is negative, so its negative is positive. Negative becomes positive. So negative of a number means a number and its opposite sign. So if you add plus minus minus, so 2 upon 3 minus 2 upon 3 will give you 0. Minus 17 upon 16 added to positive 17 upon 16 will give you 0. Minus 230 upon 117 plus 230 upon 117 will also give you 0. So my point is, if you add a number, let's say if you are adding a number A, my point is, if you are adding a number and it's negative, the result will be 0. So this particular thing will be known as the negative or the additive inverse. This is known to be a additive inverse. So the negative of a number is known to be a additive inverse. Now check. Inverse means the opposite. If this is an arrow like this, so the inverse become like this. So if the positive is this, so its negative will inverse is negative. So additive inverse, this is addition. All three are being added to its inverse. 2 upon 3, the inverse is minus 2 upon 3, so minus 17 upon 16 is positive, minus 230 upon 117, the positive 1. So if you add a number and its inverse, the result will be 0. This will be the result. The 0, if it was added over here, so it was an additive identity. Please don't get confused. This, at this point, it was additive identity. Here a number and its inverse is known to be an additive inverse whose result is 0. Alright, so if we talk about in the rational number form, so a upon b is a number, so its additive inverse will be minus a upon b, and if minus a upon b is a number, so its additive inverse will be positive a upon b. Now we will talk about the reciprocal. Now we will talk about the reciprocal. Now reciprocal, you have already known that 2 upon 3, the reciprocal will be 3 upon 2. Second, minus 4 upon 5, the reciprocal will be 5 upon 4. Third example, if you take 2, so the reciprocal will be, we need to consider 1 over here, so 1 upon 2. And fourth case 0, so the reciprocal will be 1 upon 0. Is it? Now we will discuss it. So 2 upon 3, 3 upon 2, yes, this is true. This is also correct. Minus 4 upon 5, so you require minus sign over here. So 2 upon 1, 1 upon 2, this is not true. Reason being, 0 does not have reciprocal. 0 does not have any reciprocal. Okay, so now check. If we are multiplying this, instead of if we are multiplying this, 2 got cancelled, result is 1. Minus 4 and minus 4 got cancelled, 5 and 5 got cancelled, the result is 1. 2 and 2 got cancelled, 3 and 3 got cancelled, the result is 1. That means if a number is multiplied to its reciprocal, the result is always 1. So algebraically saying a upon b, then reciprocal will become b upon a, will give you the result as 1. So reciprocal is also said as a multiplicative inverse. Pardon me for the writing, inverse. This is also said to be a multiplicative inverse. Alright, and the product of a number and its multiplicative inverse is always 1. The number and its multiplicative inverse is always 1. Now the last property that we are going through is distributivity. Distributivity of multiplication over addition and subtraction. That means if a upon b is a number, it is multiplied to c upon d plus e upon f. One is this condition, and a upon b is multiplied with c upon d minus e upon f. So the result will be a upon b times c upon d. Now this addition will come as over here, and a upon b will be multiplied to a upon f. A upon b multiplied to c upon d, and this time the minus will come over here, and a upon b times e upon f. Now check. Let's say this is one of the person and it enters to the house of another person and he knocks. So this will come and he will greet to him, greeted. Now he will greet to another person, greeted. Similar is in this case. Now if you check, a upon b is multiplied to c upon d. This can be negative rational numbers or positive rational numbers, so it will be solved or simplified in a similar the way it has to be done, like the numerator is multiplied to the numerator and the denominator is multiplied to the denominator, later on simplified if they are having any kind of common factors which you already know in the class 7. This will solve separately, this will solve separately, and later on these two will get added. Here this will solve separately, this will solve separately, after on they will be subtracted. So this is kind of a distributivity for which we can have an example from the book. Check. Minus 3 upon 4 is one of the example. Yes, minus 3 upon 4 is a rational number a upon b multiplied to b upon c upon d added to e upon f. Now this minus 3 upon 4 went to meet first 2 upon 3. Which they have done it in a manner, they've solved it first. Wait a minute, they have solved it first. You can also do it in other form. Well, we will continue with this example and then we will have it in other form. No worries. 3 and 6, they have taken the example 6 and then it is 4 and they have solved it as minus 1 upon 6, where they have multiplied minus 3 into minus 1, so this is 3, 4 into 6, 24. Now check what they have done over here. Minus 3 upon 4 multiplied to 2 upon 3 separately, so this is minus 6 and 4 into 3, 12. And simplifying this, they have got minus 1 upon 10. Now this minus 3 upon 4 has to be multiplied with minus 5 upon 6, which they have done over here. Minus 3 upon 4 multiplied to minus 5 upon 6. The result is 5 upon 8. Now the result of both, the result of multiplied to this, which was this, minus 1 upon 2, and the result of multiplying this to this, which was 5 upon 8. That is being shown over here. Minus 3 upon 4, 2 upon 3 and minus 3 upon 4 multiplied to, earlier it was getting the result minus 1 upon 2, later on this is getting the result 5 upon 8 over here, solving 1 upon 8 and solving directly with this bracket, they were getting 1 upon 8. So in both the cases it is true. Having the few examples, back to going to the exercise. For once we have write the additive inverse, so minus 7 upon 19. However, I expect after this lecture you would have came to know about the answer directly. Additive inverse means the number is similar but the sign is different. So check. 7 upon 19 is the additive inverse of minus 7 upon 19. Adding both, the result is 0. So now could you tell 21 upon 112 the additive inverse? Yes, yours is correct. Minus 21 upon 112. They are telling us to check. So you will check by adding both the things and the result should be 0. Verifying this is kind of a good example which we shall take. Solving minus and minus x is same as x. Let's check, because if we do this example over here, we are going to get one of the solution of the exercise. So additive inverse is always getting the negative sign. So x is equals to minus 21 upon 31. X, the value of x is minus 21 upon 31. So minus x, you require minus x. Well, we should solve this in the notebook. So if they are saying x is equals to minus 21 upon 31 and they have given us the condition, verify that minus x is same as x. So this is x. Alright, so minus x means applying one more minus. So this will be plus 21 upon 31. So till now this was the minus x. So till now we have reached over here. This was x, minus x. Now again minus x also has minus. So we are solving minus x. That means minus the value of minus x has become 21 upon 31. So the value of minus x is minus 21 upon 31, where the value of x was minus 21 upon 31. Both are similar. So we can say yes, minus x is equals to x for minus 21 upon 31. You can prove while taking the LHS equals to RHS kind of a thing also. Alright, now we are starting our exercise 1.1. 1.1 question number 1, using appropriate properties find the value of this entire expression. So we have written the expression again over here, and they are telling us to use the properties. So we will be applying the properties. Check, they are multiplying this, so this will be considered as a block, a productive. Now differentiating with plus, this is one of the block and this is another block as it is being multiplied over here. So these are the group of 3. So what we are doing, we are rewriting them. If you check, now by which property we have done this? By commutativity. By commutativity. That means this was as it is. Now we have taken this entire thing forward and 5 plus 2 backward. Check, 3 upon 5 and 3 upon 5 both are common. So 3 upon 5 is being taken out, minus 2 upon 3, this is a minus sign, 1 upon 6 plus 5 upon 2. Now you can recall this distributivity over subtraction. So by distributivity. Alright, so 3 upon 5, solving this, the LCM of 3 and 6 is 6 years, and 6 divided by 3, that is 2. 2 multiplied with 2, this is minus 4 and this is minus 1, while this will go along with the expression. Now 3 upon 5, now this will be multiplied, minus 5 upon 6 plus 5 upon 2. You can solve, 5 and 5 got cancelled, this we are leaving minus 1, 3 1s are 3, 3 2s are 6. So this is minus 1 upon 2 plus 5 upon 2. No requirement of taking the LCM, this will be minus 1 plus 5 and this the result will be 4 upon 2. While solving, this will give you 2 upon 1 as the solution of the rational number. So here we got as a solution. Taking up the second part of the same question, exercise 1.1, question number 1, part 2. Check again which thing is common. 2 upon 5 is over here and 2 upon 5 is over here. So what now? This is a block of multiplication. This is a block of multiplication and this is a block of multiplication separated by plus and minus. So what we will do, we will rewrite this expression 2 upon 5 times minus 3 upon 7 plus 1 upon 14 times 2 upon 5 minus 1 upon 6 times 3 upon 2. So this you can write by commutativity, because we are rearranging them. Now 2 upon 5 and 2 upon 5 is common, so if you take 2 upon 5 common out, so this will left 3 upon 7 plus 1 upon 14. This is negative 1 by 6 times 3 upon 2. Now yes, you can recall the property, this is by distributivity. So 2 upon 5, solving the bracket, 7 and 14, LCM is, yes, 14 it is. 14 divided by 7, that the result is 2. 2 is multiplied to the numerator, minus 6. 14 divided by 14, 1 of course, multiplied by 1, this will get along with the solution. So now 2 upon 5, this is multiplied with minus 6 plus 1, this will be minus 5 upon 14 times 1 upon 6 into 3 upon 2. What you can do, you can solve them over here. 2 1s are 2, this is 7, 5 got cancelled with the 5, leaving out minus 1 over here. 3 1s are 3, 3 2s are 6. So this is minus 1 upon 7 minus 1 upon 2. 2 into 4. Taking up the LCM. 28. Yes. 28 divided by 7. The result is 4 multiplied with 1 minus 4. 28 divided by 4, which is minus 7. So this will be minus 11 upon 28, which is your final answer. Well, now write the additive inverse of each of the following. Well, this is an easy cakewalk question, so you can do already. 2 upon 8, it's already been written, minus 2 upon 8, so I'm not giving you I'm going to give you the rest of the answers. Verify that minus and minus x is equals to x. This we have already taken from an example. You can also take the reference from your book in this video and try to attempt this question. We have already taken the negative one. Find the multiplicative inverse. Multiplicative inverse are nothing but the reciprocals. So the multiplicative inverse of minus 13 is 1 upon minus 13. Minus 13 upon 19. Yes, you guessed it correct. 19 upon minus 13. Well, we will have an example of this one, that what will be the multiplicative inverse of minus 5 upon 8 times minus 3 upon 7. Now, to find out such an answer, first you need to solve this thing. So minus got multiplied with the minus, this is plus, so 15 upon 8 7 is 56. Since this is the result, so the multiplicative inverse will be 56 upon 15. So this will be your final answer instead of doing the separate question. So you can also do it like 8 upon minus 5 and 7 upon minus 3. In this case also you are going to get 56 upon 15. Okay. Well, name the property under multiplication used in each of the following. So try to solve. Well, this has been multiplied with 1. Result is 1 into minus 4. So always, so something multiplied to 1, you are getting the multiplicative identity. Here 13 upon minus 17 is multiplied to the minus 2 upon 7 and later on. So A is multiplied to B, that is equal to B is multiplied to A. Yes, that is commutativity. Here minus 19 upon 29 times 29 upon minus 19. If we check, these are the reciprocal. So yes, this is multiplicative inverse. Multiplicative inverse. Now, question number 6. We are taking up the question number 6. Multiply 6 upon 13 by the reciprocal of minus 7 upon 16. 6 upon 13 is to be multiplied with the reciprocal of minus 7 upon 16. So 6 upon 13, the reciprocal of minus 7 upon 16 is 16 upon minus 7. The multiplication of numerator to the numerator, this will be 60, 96 and this will be 91. So this is your answer. Tell what property allows you to compute 1 upon 3 times and the bracket and check. In this case, A upon B is multiplied to B upon C. We can take 1 at the denominator times A upon F. Now, first this bracket has to be solved. Yes, you can recall the property of associativity, where 3 things are multiplied in any order, the result will be similar. Yes, so this is the associativity. Now, we are taking up the question number 8 and 9. Question number 8 says, is 8 upon 9 the multiplicative inverse of minus 1 whole 1 upon 8? Why or why not? So 8 upon 9, is it an inverse, multiplicative inverse of minus 1 1 upon 8? Well, this is in the mixed fraction. If you are converting it to the improper one, minus sign, 8 ones are 8 plus 1, so this is 9 upon 8. Now this is minus 9 upon 8, and they are asking whether this number is the multiplicative inverse. Now you know that multiplicative inverse always gives you a result 1, so the multiplicative inverse will be a reciprocal. That means this is the reciprocal, this is the correct answer. Match whether this is the correct answer. No, it lacks the sign of minus, so we will say no, 8 upon 9 is not multiplicative inverse of minus 1 whole 1 upon 8. Question number 9. Is 0.3 the multiplicative inverse of 3 whole 1 upon 3? Now 0.3 is the multiplicative inverse of 3 whole 1 upon 3. Again this is in the mixed fraction, so 3 into 3, 9 plus 1, 10 upon 3. Now the reverse of multiplicative inverse, you need to find the multiplicative inverse of 10 upon 3, so you will need to reciprocate it to check. Yes, they are getting the result 1, so this is the multiplicative inverse, but they are saying, well, check, is 0.3 the multiplicative inverse? So 3 upon 10, if you will divide it, it will give you 0.3. Yes, so this was, they have given it in a decimal form while they were looking for the answer in a rational number form. So we can say yes, 0.3 or 3 upon 10. So you can also show them how 0.3 can be written as 3 upon 10 by taking up the multiplying and dividing by 10. So this will be 3 upon 10. So is a multiplicative inverse of 3 whole 1 upon 3. Here are the few exercises for you. Well, you will do the question number 10 and 11 by yourself, and if you'll find any doubt, you'll post it in the comment section. Now we are having two major topics for your last exercise, and this is representation of rational numbers on the number line. And for the summary point of view, let's get back to what is the number line. If you are, they are showing us the natural number lines. Well, natural number starts with 1, so they are showing the natural number line which is starting with 1, 2, 3 and getting along, and this arrow represent it has been extended to the infinity. Alright, and the smallest number for the natural number will be 1. For the whole number line, it starts with the 0 and goes to the right direction for the increasing order. Integers, well, they can be moving toward both the directions, well, to the negative side also and to the positive side also. But check, whenever you move to the right hand side, whenever you move to the right direction, the numbers always gets bigger. 2 is bigger than 1, 3 is bigger than 2, 4 is bigger than, so well, this will be 5, 6 and 7. So if you are moving more toward the right direction, more you are getting the bigger number, and if you are moving toward the left direction, more you are getting the smaller number. So minus 15 will be smaller than minus 3. Why these things are necessary? Because we are recalling all these things for our further purpose. Now rational number. Rational numbers means all those numbers which are between this minus 2 and minus 3, minus 1 and minus 2, and that can be represented in the form of P upon Q. So we will try to represent the rational numbers now on the number line. Well, to represent, let's say we need to represent minus 3 upon 4 on the number line. This is one of the example. And second example we will take, let's say we are representing 7 upon 4 on the, again we have taken the 4, so we will take the 7 upon 6 on the number line. And third we will have minus 2 upon 11, minus 3 upon 11 and minus 9 upon 11 on the number line. We'll take these 3 examples, and you need not to do anything apart from 3 basic rules. First, draw the number line that is required. Find out whether this is the negative, so take the positive one only till 1, just for the representation, sake of representation, and this is minus 1 and this is minus 2. Well, for your information, you need to, the second step will be identify the denominator. If the denominator is 4, the number at the denominator will tell you how much segment you need to do. If the number is 4, that means you need to do 4 equal segments, 1, 2, 3, 4, or you can count 1, 2, 3 and 4. Again 1, 2, 3 and 4. Try to make them uniform and equal. Well, now you will start. This will be minus 1 upon 4. This will be minus 2 upon 4. This will be minus 3 upon 4. That means you got this point as minus 3 upon 4. Now there is no further requirement to move. Again, for this number line, this was positive, so we will take 0 over here. A simpler representation of 1 unit, and we will take 1 over here and 2 over here. Now, how many parts? Denominator. Identify the denominators. First, you need to identify the sign. So this was positive, so we are moving toward this direction. Second, denominator 6. 1, 2, 3, 4, 5, 6. Again 1, 2, 3, 4, 5, 6. So again, this one is your 1 upon 6, this is 2 upon 6, this is 3 upon 6, this is 4 upon 6, this is 5 upon 6, this is 6 upon 6, and this one you got as 7 upon 6. So this one is your required. You need not to write this. You need not to write this in the paper or while representing the number. Simply you need to point out the required which one is. Well, now you got it easy. You might be gaining the confidence to represent these things. So these are all negative, so I'm pointing 0 over here, then the positive will be like this, and we are having minus 1 over here and minus 2 over here. Well, denominator 11, so be careful while choosing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1 upon 11 minus 2 upon 11, so 1 is this, so we will write this as an arrow, minus 2 upon 11. This is minus 3 upon 11. Now 4, 5, 6, 7, 8, 9. So this one you got minus 9 upon 11, minus 10, 11. Now check. I'm just giving you for the check. This came as minus 11 upon 11. Yes, it is correct. 11 and 11 will get cancelled. It will result you as minus 1. 6 and 6 got cancelled. It will give you 1. So you need not to do anything. Only one representation. Whatsoever is in the denominator should be as an equal division between the units. Between the units 0 to minus 1. Now we are moving up toward the next topic and the last topic, rational numbers between two rational numbers. And for this you have in your exercise 1.2, that is question number 4, question number 5 which have 3 parts, and question number 7. We are having this part and the rest you can already follow. Minus 3 upon 2 and 5 upon 3. Now just focus on only the steps. If you'll get the steps, you can solve any question related to this topic, that rational number between two rational number, and you can also find as many numbers as you want, not just 2, not just 10. You can find 100 of rational numbers between these two rational numbers. So the very first thing, when the denominators are not similar, or when it is not even the denominator, if we say find the 10 rational numbers between these two, so you need to make 2 upon 1 and 5 upon 1. Well, we'll deal with this category later on. If not, just try to convert this concept over here by getting the denominator as 1. When the denominator is not similar, try to make them similar, and for the making denominator similar, we require the LCM of the denominators, and in this case it's 2 and 3, which will be 6. So minus 3 upon 2. To convert the denominator, we'll use the equivalent fraction method that you have already learned in the previous classes. This will be 2. So this is minus 9 upon 6 and this is 10 upon 6. Well, check. As of now, if they say find 3 rational numbers between these two rational numbers, you may get it now. But we are taking up a condition where if they will say find 50 rational numbers between these two rational numbers, so what you can do, you can extend their limits. So what we will do, we will multiply with 10 and 10 in both the cases. it became minus 90 upon 60 and it became 100 upon 60. Now check, this is minus 90. If I take you to the number line, it was 0 1 2 3 1 2 3, and this is minus 1 minus 2 minus 3 minus 4. Minus 90 will be somewhere till this end and 100 will be till this end. So you have many numbers between over here, but while writing, I'm pointing out very important point over here. While writing the rational numbers between two rational numbers, you cannot take these two, you cannot take these two, you cannot take these two. That means you cannot take the range. You need to take the numbers which are between this end and this end. So the numbers all that lie between this end. So we can say, take the number from minus 89 to 60, minus 88 to 60 upon 60, minus 87 upon 60 will go on as minus 1 upon 60, 0 upon 60, 1 upon 60, 2 upon 60 till 99 upon 60. Yes, till over here, because we cannot take 100 upon 60 and here we cannot take minus 90 upon 60. So one simple method, I am repeating it again, the steps: find out the two rational numbers, make the denominator similar. Once doing the denominator similar, you will get the rational numbers when the denominators are similar. Try to extend the limits if the numbers are not sufficient between them, that is by making the equivalent fraction. Once done the equivalent fraction, find out the numbers between them, as many as you required. Now getting back to the exercise, represent these numbers on the number line that you can already do. Draw the number line. This is positive, move toward the positive one. Find out the denominator, it is 4. Mark 4 equal segments between the units and just count out the lines. Similar is the question number 2, which I have already done with the different numbers. Question number 3, write 5 rational numbers which are smaller than 2. Now smaller than 2, check. This is 2 over here. Smaller means you need to move left, that I have already told you in the video. Moving toward the left will give you the smaller numbers. Moving toward the right will give you the greater numbers. So 1, 0, minus 1, minus 2 and minus 3 are the rational numbers. If you need to write in the rational number form, you can use the denominator as 1. Question number 5, 4, minus 2 upon 5 and 1 upon 2. One simple case. Try to do the denominator similar with the equivalent fraction method. Extend the limit and write down the numbers between them. Similar is this case. Write 5 rational numbers greater than minus 2. Now greater than minus 2, that means you need to move toward the right direction. You can have as many numbers as you want to, and of your choice even, and just put the 1 into the denominator. That will be 3 upon 1, 4 upon 1, 5 upon 1, 7 upon 1 and any. Find 10 rational numbers between 3 upon 5 and 3 upon 4. Well, exactly the similar method. 5 upon 4, the LCM will be 20. Equivalent fraction, 3 upon 5, 3 upon 5, 4 upon 4 and 3 upon 4, 5 upon 5. This is 12 upon 20. This is 15 upon 20. We need to extend the limits. So we have extended the range. This is 120 upon 200 and this is 150 upon 200. Now you can see the range. These two are similar, doesn't matter. Range 120 to 150, the difference is of 30 numbers. So you can choose any 10 numbers between this. So it will be 121 upon 200, 122 upon 200 till 149 upon 200. So here it may be quite fast for you, but I hope this video will help you out to do the complete chapter 1.2. Try to finish up the exercises and do the questions from the internet, and if you have any doubt, just post it in the comment box. And thank you. We'll come up with the next video of chapter 2.